Welcome to our talk here. This talk is coming from the perspective of a customer of all these technologies that we're here, rather than, say, a vendor or somebody providing code. So you'll get spared a commercial from a vendor in this session, except that we will do a commercial for T-Mobile. This is called Observability at Scale, and a good play on words. Observability is a key tenet of multi-tenancy for us at T-Mobile, and we're going to talk to you about a specific solution that we have using containers at scale. To give you some idea about T-Mobile, here comes the commercial. We've grown quite a bit over the past 4 years. T-Mobile 5 years ago was the fourth largest telecom provider, wireless provider in the US with about 35 million customers. It's now the third largest with 77 million customers over the last 5 years. And the reasons for that is really a real focus on customers, providing things like Netflix on us. We have actually real humans doing customer service, taxes included on the bill, unlimited voice, data, and text, and we give you something every Tuesday. And in case you didn't know, the people really like free pizza. So when we give somebody free pizza, it usually puts a pizza shop out of business for a day or two. We're going to try to do a handoff here.
So as Tom said, like, we grew from 35 million customers to about like 77 million customers today. So most of the pretty large systems that we run are running on cloud. And for most of that, we do the observability based on this particular system, what we build. So T-Mobile operates in two brands. One is T-Mobile, and recently Metro PCS got rebranded to Metro by T-Mobile. And we have over 50,000 employees, which I came to know just a few days back.
About 5,000 of which are developers, software developers, employees or contractors. So it gives you some kind of sense of scale in terms of people that we deal with. But in terms of solutions, we have different parts of the company. There's an engineering part of the company focused on like the network. We're from a part of the company focused on customer experience. And to provide all the customer experience that we have, there's about 10,000 APIs across T-Mobile. We've seen massive adoption internally at T-Mobile and a migration to microservices and container-based technologies, both in our data center and the public cloud. Amreth and I are from our public cloud team. In our public cloud team, we've started with Docker-based applications about 3 years ago and have built up slowly to a large shared multi-tenant environment with multiple cluster technologies. So it's been about 6 years. We have about 70 plus applications, and applications is loosely defined, across AWS and Azure, primarily AWS. And we have all of our regions we have in both clouds integrated with our data center network, so it appears as one network that we can take advantage of. Of those 70 applications, about 40 are container-based applications, doing things like our Netflix integration or coverage maps, which we could show, and that's a specific Kubernetes-based application running across both data center and cloud. Our T-Mobile for Business, our commerce. There's just a lot of things that we do in terms of serving customers in different markets that add up to large number of teams, and serving those large number of teams for 77 million customers that ends up being challenging. So we thought we'd pass on some lessons that we've learned in going about that. So as I said, we started 3 years ago adopting containers, and we built out a shared cluster. And there's some things on here that are actually true. They're not going to sound believable, but we really think there's a big win in taking an approach. If you're an organization like ours that has multiple, what we call customers, our customers are actually our internal application development teams. And we provide shared clusters that enable us to have a consistent approach rather than 4 years from now ending up in a situation where we might have thousands of Kubernetes clusters out there and all different sorts of configurations and secrets management and telemetry tools and logging tools. We have a pretty consistent way to produce the clusters that we have. Today, on the clusters across these two technologies, there's about 7,200 containers running. That ends up being about 31 billion requests so far this year, API requests, ranging from anywhere from 2,000 to 14,000 requests per second. During the time, in the 29 months we've been running these container platforms, we have not had a single minute of downtime in the production clusters. We have had 0 P1 customer incidents as a result of things running on these clusters. The biggest reason for that is observability. And we'll walk through what we've done to make sure that that's a default choice for every application team. The second biggest reason for that is luck. And you all know that to be true. We have done everything. 3 weeks ago, an etcd cluster went down, got corrupted. That happened in non-prod. We've been this close a number of times of having this streak broken, even in the last week, where we had a misconfigured ELB and a misconfigured console service. But we caught it in testing. So we've been very close a number of times to ruining this record, but by luck and by doing some of these principles that we'll talk about, we've avoided actually having these systems go down. We have built a set of tools that we call internally Conductor. You can see the logo up there. We could spend a whole session talking about that logo because it has a duck in it, but we're not going to do that right now.
Actually, you can see quite a resemblance of the Kubernetes logo. This is a seven-sided figure, and you can see our Conductor as well, a seven-sided figure. So we just took that as an example, and you can see a K with a duck. That's K for Kubernetes. So that's how we just started to play around, and then we actually started creating an internal tool. There's a whole lot of things we started doing with Conductor. So like 2-3 years ago, before we started creating these platforms, there used to be like 12 teams whom you had to go to just go live with a single container in production. So you had to create a DNS, you had to go create a logging system, you had to get certificates and all those things. So we basically automated a lot of these things. So all these are the integrated services, what we automated, including security scanning, service discovery, secret management. And with Kubernetes and with today, we have about 14 Kubernetes clusters, which is pretty large scale, which can handle 600,000 requests per second. So we did perf test, we did a lot of things, which is the base of what Conductor is. So that's what you see, the different logos, whatever we use. So we use Kubernetes, obviously, we use Helm for deployments, and Heptio has been a partner for us to, scan and also check the reliability of our Kubernetes clusters. We run Docker, we're just testing with Containerd as well. We use Weave, CodeDNS, etcd, Nginx. Nginx is our ingress basically, so that's where we perf tested 600,000 requests per second, basically because it's large scale. Teams, because we are a platform team, generally teams don't come to us and tell us that, hey, we are going live and scaled up the systems. They just go live. And they go live from 2K requests per second to a 14K requests per second within seconds. So nobody tells us that, okay, we are going live. And probably we'll just show some metrics on how it happens. So being prepared is one of the things, and observability plays a key role in that because we know how much our systems can handle and when the system can break. So that's where all these different tools and services, what we're going to talk about, is very important. We use Ansible for automating the provisioning of Kubernetes clusters. We use the upstream version of Kubernetes cluster, which means whatever is open source, we take that, we automate it using Ansible, Puppet as well, and Terraform. JFrog is our Artifactory, where that's our centralized Docker registry, where I think there's possibly around 15,000 or 20,000 Docker images. we use Claire to scan all those Docker images and tell the teams that, hey, these are vulnerable and you need to go and fix those. We are playing with Harbor as well for signing those Docker images and making sure only signed Docker images are being run. So because we are have two different teams, one is on engineering, which is on data center, we as public cloud, we want to make sure every cluster is going through the same process of signing those images. Of course, we run on AWS on a pretty large scale. Yeah.
So that's kind of the stack. So you get a baseline of what's running underneath. And now what we'd like to do is just kind of walk through what we think is where we're going, or where the path, not just us, where everyone's going in terms of observability. And we're going to add to the definition of observability when we talk about some of the data we're collecting. But first, as we talked about, is building the culture. When you start, you're basically starting with data collection. Even last week, we run into an application where they didn't have logging. The data's just not being collected. So it's a large organization. There's lots of legacy, applications out there. So we're trying to continue to make sure we improve that. And what we're going to do today is show a demo after this where you'll see as you build an application, you just basically can't avoid logging unless you really screw things up. You can't avoid having a Grafana dashboard. It just is built in. So we want to encourage application teams. We have a model where we have proactive engagement. I'd say another factor in us being able to keep our production clusters up is we treat our non-production like production, and we proactively engage development teams when we see an error. We have all of our alerts flowing into Slack channels and many other places to be where the developers are, and our team proactively engages them when we see those errors. In order to get to what we think is the promised land of observability, which is you got to walk through each step of this. You got to do your data collection. You got to turn that data into information through telemetry tools, dashboards, reports, and service health monitoring. Then you have to create the culture that uses those things. Doesn't matter if you're creating dashboards, somebody's got to use them. You got to create alerts on those things. Those alerts need to have more noise than signal. And you have to integrate telemetry and all the tools that you build. We do build internal tools that help people on board to this. So we want to integrate telemetry into those tools and integrate all the data into those tools. A big factor for us being proactive is chat ops and Slack, and making sure we have dedicated teams and dedicated channels to support teams and applications in Slack. So then we've walked 3 steps of the path, but then there's another place, another direction we can go, is now we have all this data. We have data coming from Prometheus. We also have another piece of data on here that I've added that you probably haven't seen in observability talk, which is cost. Since we're on the public cloud, you have to look at cost pretty rigorously. And so we integrate the cost data into this, and we do trend analysis. We do some optimization, and we're starting to get to the point where we're adding machine learning to that. So ultimately where we want to be is today we're in a situation where every team who onboards something is making a request for memory and CPU. We want over time our system to be able to make decisions on what the memory and CPU utilization should be for those applications.
We have seen some applications actually, for 1 request per second, they have like 4 CPUs and 16 GB of memory. Seriously. So we do talk to these application teams and tell them that you need to do an actual performance review and do a performance optimization of these applications. It's pretty easy to scale containers, right? I mean, you can even have like a 10 CPU and a 50 GB memory and then scale like 100 pods and you can run it. But do we actually need it? So since we do a lot of cost analysis and everything, we do get back to the team and tell them that, hey, you know what, you're going to costing us like $3,000 an hour. That's a lot of money. So go ahead, go fix your particular applications, and since we are a platform team, we know what all services that runs on a platform, and we can actually go and tell them that this is a very inefficient way of running it. So in the process of that, we actually have teams who have reduced their consumption by 1/10, which is actually quite significant because some like 40 containers to like 4 containers. And it basically, on a bigger picture, you can actually see millions and millions of dollars throughout a year, right? So it's actually quite a lot of money.
So Amreth will take you through the details on the tool set we use for collecting the information.
So this is a toolbox. As you can see, we run like 28 Prometheus clusters. So as I said, we have like 14 Kubernetes clusters. Each of those Kubernetes clusters has a Prometheus cluster, and each Prometheus cluster is highly available, which means to say that at least 2 run on each of those clusters. And we have integrated that with Thanos, which is an open source solution for it to have an infinite retention period. So even if you go 2 years behind, you can actually see the data for each of the system, including non-production and production. It's not going to cost us a lot of money in this case because we are storing this in S3, which is like very cost efficient. Probably like a 300 terabyte might cost you like a few $1,000 maybe. So which is not that much amount of money given the fact that you have to have, like if you want to go on a phone launch or whatever it is every year, you want to go look back over a year and see that how much is your resource consumption for it and how much time will be prepared for something. Because we are a telecom provider, we need to have all those data metrics, and it's quite useful. We store like about 1.5 million metrics in total, and more than our customer requests that comes at times, our telemetry requests are more. Like we get like around 4,000 requests a second. They're the metrics what we ingest into our Prometheus clusters. We collect from every single container, every single pod that runs on every EC2 instances in AWS case, every ingress controller that runs, even HA proxies. We do get a significant amount of data what get dumped into Prometheus. And we do a federation on top of that and collect valuable metrics and store a different Prometheus cluster. And that gets collected to a data lake where we do all those machine learning and data processing for cost analysis, build dashboards that go and talk to application teams that basically this is how much you have grown over a period of time. This is your consumption in total. This is how much you can save. This is where you have seen issues on your application because of CPU and memory utilization. We have seen applications with like 1% utilization. And we go on, I think pretty much everybody here would have worked with these applications or built applications like this. And if you actually look back into those telemetry systems, you actually see like this is not the most efficient way of running your services. In Grafana perspective, we run 150 orgs in total, which means to say like there's at least 50, 60 applications in non-production and production put together. It'll be like 100 plus. There are like thousands and thousands of dashboards that's built by our team, that's built by the application teams. And there are like more than 820 alerts. Just creating alerts is not most useful. You have to go and revisit the thresholds for those alerts as well. Like 2 years down the line, if you just create alerts, that is very insignificant because like you would have created alerts for like 10 requests per second, but now we have grown to like 2,000 requests per second, and it will keep alerting. Once you keep alerting, it's going to be a spam on your mailbox or on your Slack channels, and nobody's going to go and look at those. So it's very important to go and revisit those alerts as it actually makes sense. That includes network thresholds as well, the bandwidth for each of those instances. AWS keeps optimizing their instances, so we go and move to those instance types. That means to say you have to go back and fix those thresholds, whatever you have done. And every single of the clusters are highly available. So Grafana itself is like 99.99% availability. We run Grafana in multi-region. So even in a single region, we tell our teams, like our customers or our application teams that, okay, it's 99.95% available. If we run on multi-region, if the entire region goes down, Grafana is still available, it can still alert us. On top of that, we have built a service dashboard. Even if the entire cluster goes down, that system would actually alert us even if everything goes down. That is sitting just outside the Kubernetes cluster, outside the Grafana. It is entirely independent of all these systems. So that is in-house build system which we plan to open source. Actually, we want to open source today, but we'll probably open source probably a few weeks down the lane. So we saw a need for a service dashboard that can support both Mesos and Kubernetes. So this can actually go and monitor every single pod that is running, every single service that runs on Kubernetes, and every single service that runs on even Mesos. You can even have a generic alert for TCP or even HTTPS endpoint, and you can subscribe for email, Slack notifications. You can pretty much do everything on that. Even Prometheus is highly available. We have built Prometheus on a multi-region. So both the regions go and collect information from all these pods that is run. Even if both Prometheus clusters on the west region goes down, we have on the east region that is already highly available. We are working with Uber M3, which actually does the data replication between Prometheus clusters. We are doing a POC with that as well, because Prometheus is a standalone time series database. It doesn't do replication between databases. So we do work on that. So below are some of the tools like Prometheus, Grafana, Fluentd. CollectD actually is what we use for log aggregations, data collection, sorry. And we use Elasticsearch, Kibana, Splunk, Thanos, which I just talked about, InfluxDB, and cAdvisor for Kubernetes, where we collect metrics from all the pods, node exporter of Prometheus to collect data. We try to collect as much data as possible and make meaningful use of those data. Just collecting the data and storing is not useful. We have to build dashboard that is actually used by applications. In fact, like there was one application that went live, and before that, nobody was even looking into these dashboards, but there was a different monitoring system which they used, which they collected an incorrect memory. So even we went to a depth of actually writing our own scripts to collect memory properly, and we built dashboards on top of that. And there are like 150 developers requested requests for these dashboards, which they're going to show because their application went live and they want to see what all metrics that's getting monitored. And they went ahead and they optimized most of their monitoring solutions.
Yeah, one important concept here is not only to monitor your infrastructure, monitor your applications, but also monitor your monitoring, which is something we did from a really early point in the process. Another concept is as I said earlier, build telemetry everywhere. So one of the things we do, as you see on the right-hand side, is we integrate into Slack. We have internally public channels on every alert that fires in our clusters so that anybody can see it, and importantly, our team responds. We build a CLI internally such that we can combine all telemetry aspects into our CLI, so you can actually get not just container level data, cluster level data, but EC2 level data, all in one place. And you can see this particular example we filtered by EC2 instances. So just making sure the concept is be where developers are, live where they are, and provide the tools in every place they might be.
So if you're confused with duck, it is nothing but conductor. So we use that duck as an acronym just for this being funny team, and then onboard those applications into us. So because we support multiple levels of customers, so these are those applications that belong to us or using our system.
Right. So what we're going to try to get to a demo, so I'm going to rip through, as long as the demo goes well and the demo gods are good for us, rip through some of the telemetry dashboards just because we like to show cool dashboards. And first level, obviously we have to do a good job ourselves of making sure we have dashboards available to our own team, and we have probably 100 or more dashboards just specifically to our platform measuring things like health status. Oops, sorry. This is one of the important concepts is when you put a tool out there for our application teams, we want to encourage them to use that tool and be self-service and self-sufficient. And this is one area where we're not generating these dashboards, our teams are. And to us, that's a great sign that we've reached a certain point when you get this level of detail about one specific application. And then seeing, something like an API dashboard for the same application where they're measuring each component of the application, the response time, request rate, cache hits, all different sorts of attributes of the dashboard. So I just think it's great that, and this is diving into one of those services to say, okay, I want to learn more about what's going on in this particular service. So just getting that culture, getting those dashboards up and running, putting those tools into people's hands is really important. Then what you get after that is people learn that they can do different things in Grafana. And this is an example of a call flow dashboard on an API where you can see that they're measuring the call flow as it goes through. In some places it's green, which means it's operating within its SLA. In some places it's orange, which is not quite in its SLA. And so they can look at every level in the request. Here's another one which is interesting, that we have a retail application that's deployed both to the east and west region, and they can see the traffic flowing east or west, so they can determine the health based on region availability. So just a wide variety of things we've seen developed, dashboards we've seen developed by our customers, which are internal teams. And yet another one here, just different ways you wouldn't think of using Grafana and this telemetry platform to see order numbers in just a table format. This one I love because I don't know if you know, but Grafana can have white backgrounds. And I, for one, exactly. So I don't know if you know where I'm going on this. I am a person, when I look at white text on black screen, I get dizzy. And I'm curious how many people in this audience are like that, or is it just me? So we have this really big problem. So yeah, so Mojave dark, no, not a fan at all. So I mean, the reality is for dashboarding, obviously black makes it pump better, but I thought I'd show you this example because it really hits home for me. Talked also about cost. It's important for us, especially in the cloud, to be able to drive costs. And I've got a few screenshots here which are intentionally blurry, so we don't tell everybody what we're spending everywhere. But the point is, you can see from a very high level of our total AWS spend, and this is AWS, and we have an Azure one as well. But we drop down into specific people, specific projects. Each project, each line item, each application has a budget, and we continually test against that budget. We look at, you can see in the top right hand corner, a drill down from the bottom left, which allows you to look at a specific application, and you can see the breakdown of the cost on AWS line items, and then further break it down by usage type in AWS. So if you really know all the line items in the bill, you can get really granular about looking at what you need to get. And we also have the same capability on Azure as well, as you see on the right-hand side, in addition to providing folks with a daily trend as well when you're doing things like launches and bringing up new applications. So cost is a really important part for us in helping to drive system performance. And as Amreth mentioned earlier, we pull all this data, all the Prometheus data, all the cost data, into a data lake. We analyze it, we look at utilization. We did a project where we used Spark to look at the utilization, and we found out some interesting things. Some are obvious, but some obvious things only jump out when you put them in data and look at it. So we saw that our average utilization for memory, the first thing we found out is that whenever you're talking about utilization, oftentimes people think about CPU. Well, in a stateless environment and for 97.9% of our applications, CPUs just isn't a factor. It's memory. That might seem obvious to us, but when you look at the data, it's even more obvious. And so 51% utilization, not so bad across a wide variety of applications, but there's a number that should stand out to you that looks just really strange here, and that is the standard deviation of that number, right? So we've kind of looked at a standard deviation of 30, seems kind of high for any data set. So we looked at that and started measuring the standard deviation of memory utilization across our entire set of clusters, which will turn out, if you do that and you reduce your costs. I think if everybody did that in this room, we might actually put one of the cloud providers out of business. So there's tremendous savings available by focusing on this. And what I'm trying to say up there in the title is basically when I end the slides here with a question mark, and that is, what is your standard deviation of memory utilization? And so figure that out, and you really start to get progress, and we've had some really good results based on that.
So actually, one more point here is the number of short-run containers. So starting off the year, in February, actually Thom gave those statistics. Like we ran like about like 60,000 or 90,000 short-lived containers in just February month alone. Later in August, it was 450,000 containers, short-lived containers. And in November, December timeframe, it's like 600,000 short-lived containers. So what are short-lived containers? Those containers that run less than a day are short-run containers. It can run 2 seconds because of some restarts, or it can run like our Jenkins slaves run on as a Docker container. It runs depending on the pipeline length. It could be for a few minutes. So even the demo, hopefully I'm going to show, is going to run like that. It's going to run as a Docker container. So those are what the short-run containers are.
Okay, good. So, and switch over to the demo.
Yeah.
I probably should have done that while we were talking. But yeah, I mean, that's actually an interesting point, and one that kind of really gets at, everybody's talking about DevOps and agility and continuous delivery. But when you see a very high percentage of your containers that run short-term, you're starting to get there. That you see, really quick iterations. We have very few over a month. You might have less than 5% of the containers run the entire month. And so just another kind of thing, another little data point you can look at to do that. So go ahead, we're going to show the demo here of basically what we're trying to enforce here is just make the default path for developers easy to get telemetry integrated into the system.
So hopefully the demo guys are there with us and everything works. So this particular demo is about usual developers day, how it goes. So a developer comes and it's like there's an issue for this particular application, and he wants to have more replicas for high availability of his application. So say he just wants 3 replicas for his application, or even make some code changes. Let's say, okay, add Seattle, and you just want to commit something. And so this one is, so this gets checked into Bitbucket, and now it gets triggered, and a Jenkins job gets triggered. And now the Jenkins pipeline is going to run. So it's going to do, this is in Golang. So it's going to do a Golang build, it's going to do a Docker build, it's going to go and push it to Artifactory. And once it pushes it to Artifactory, it's going to go and deploy into Kubernetes. And as you can see here in the dashboard, and this particular system as well, this doesn't exist. So this particular system or this particular application doesn't exist. So you can see all those metrics, what we have for RPS, error rates, latency, bandwidth, everything is 0. So once a developer checks in his code without even doing any sort of monitoring or having an APM solution that is running, all these agents that is running on this particular platform collects all these data, ingests all this data, and send it to Prometheus. And like in 30 seconds after deployment, all these data is visible. So hopefully the pipeline, the pipeline is triggered, and you can see that it has done the, it has pulled from the Bitbucket, and now it is doing a build. It's doing a Docker build, and now it's going to push. So since it's, like before it, while it's doing, so I'm going to talk a little bit about the other thing as well, where we have Locust as a performance testing tool. So this is an open source tool that we use for testing, and we use this tool to run 600,000 requests per second on our Nginx clusters. So this can scale how much ever you want. So say an application developer checks in his code, and now he sees the metrics, he want to do a performance testing on top of his application, what he has. So we're going to use this tool to load test on this particular service, and you can see all those Grafana graphs goes dynamically as per whatever request we are getting here. So
how that's working, I'll ask you a few questions. If you go back to the Grafana dashboard. So what we're seeing here is a set of Grafana dashboards. Do these dashboards, are these the standard dashboards that come for every developer?
Oh yeah, so this dashboard is standard for everybody. So this is a self-service dashboard. So even if you have like hundreds and hundreds of applications and they have like thousands of pods and thousands of containers that runs, all the developer has to go and do is like go to the host and choose whatever host you have, go to the upstream and choose your particular namespace. And this was one of the previous examples. And not only that, you can actually go to those pods and see how much is your CPU utilization, how much is your memory utilization, what is your consumption of network bandwidth for your different services. So basically the developer did not do anything. All he did was deploy his service into Kubernetes, and he's seeing all these metrics that's already available. So I'm just checking if the Jenkins, yeah, so actually now the deployment is done. So it's asking for a staging deployment, which I'm going to wait. So you can actually see whatever I checked in, I added Seattle on a timestamp, so now it is available. The DNS is now available. And I'm going to refresh this system, and it probably just got deployed. You can see those metrics started coming immediately. So previously you saw everything as not applicable because that service was not running and the service was not available into the Prometheus system. And now the data, the C advisor, the collect agents that is running on the host is collecting all those systems, and it is now sending, and Grafana is getting those data, and you can see all this. So now what I'm going to do is I'm going to do a perf test. So I'm going to pump in like 100 virtual users, and I'm going to scale with 10 requests per second, and I'm going to start trying to see like, okay, how much request can my application handle? So you can see immediately there's like, it has started running 100 users. This can scale to like even 100,000, 200,000 users depending on how many slaves it has. We have tested it to its limits, and we made some lot of customizations on top of it. You can see it's running at 312 requests per second. This is what the load testing tool is actually showing. And if I'm refreshing here, it started to get that data. So you can actually see those data that is coming here, and you can see all those server requests, and you can actually see those upstream requests and everything that is starting to come in. You can actually see like the request per second has gone to like 454 requests per second. You can see these upstream requests as well. So this particular system is actually collecting all those information, and it is showing all those errors, latency, bandwidth. And not only that, it can actually show the CPU utilization and the memory utilization of these. You can actually see there's a little spike in CPU. So what we can see here now is like there's an inefficient way of using CPU. Like basically I'm requesting for a lot of CPU, but the CPU utilization here is like very, very less. So I have a lot of room for optimizing my CPU, my memory, without even having any sort of application monitoring solution in place with your application. So not only with pods, you can actually go to a container dashboard, and you can see the number of pods that is running. You can actually three pods are running, and it can even show you on which particular host it is running. It can show you information about each pod and what is the utilization for each pod. Like over a period of time, over a period of time, once it goes to production, we have seen applications with like 4,000 requests per second or even like 10,000 requests per second. And you can actually see those utilization metrics for each of those services. There are times where application teams run like 450 containers. You don't need 450 containers for like 100 requests per second. So this actually helps application teams to determine what is their consumption and how much they want to use. And so you can actually see this load testing tool is actually showing all those information as well, but it's probably available to a load tester. But now this is also available for an application developer to go and check it. So along with this, like I want to show our service and dashboard as well. So this is our live production system, how much data it's actually getting consumption. You can actually see our production system is getting slammed with 10,000 requests per second. You can actually see how much it has grown. It's 6,000 requests a second, probably during the night time where there's less traffic. And now it is like about 10,000 requests a second. So you can actually see the difference and the scalability of this application. Like today, in every 2 days, we reach 1 billion requests per second. So which means like every day there's like we average about like 500 million requests per second on our platform. There's about 3,000 services with 6,000 plus container that runs. And you can actually see how much is on Mesos and how much is on Kubernetes. And you can actually search with different platforms together across our different clusters. This is what we're actually planning to open source in some time. So yeah, please watch out for that.
And one more thing to show on this is the integration here. Anybody can subscribe to a particular application and send these health alerts, for example, to a Slack dashboard, and that's just something that's built in to the application. So just, again, building the tools to enable developers to have this all by default and available.
So this is what is like monitoring a monitoring system. So this is the standalone monitoring system that is running outside Prometheus, outside Grafana. This is just a simple health check tool. All it does is talk to Kubernetes, does a health check, talk to Mesos and see the health check, and then it stores that information and tells it, okay, what is your availability, how much is the request per second for each of those applications. So yeah, that's about the demo.
That's where we're. I think we have 3 minutes left in the session. If anybody has any questions they want to ask about anything we're doing. Go ahead, I'll just repeat the question.
It looks like your load is really dependent on the time. Do you guys have any kind of like auto scaling?
Yeah, so the question is about our load is dependent on time, which is true. We do have hours where people are awake and ordering things, and the question is, do we have pod auto-scaling in place right now today? So that's, the answer is not 100% yes yet. I think that has to be a coordination between the application team and the platform team to make sure the application knows how to go up and down. We've seen with scaling, the bigger problem is not scaling up, it's scaling down. And you see where an application might have 10 containers. Where it gets to be a problem is applications that might have one service running in one container and having to relocate that. So yes, ultimately when we get further along, the application teams will be more aware of the capability of pod auto scaling. Go ahead.
So is the tool what we are showing for the cost? Is it done by us?
Is the tool we're using for cost, is that something we could open source? It's a little, basically what we do there is we could open source like the data model that we have, right? So that would be one thing we could do on that. We basically, that was Power BI that you saw. That data is loaded up into Azure actually and munched in there. So yeah, we could, the open source part of that would just be kind of like, how do we do this?
Yeah.
Sure.
So it's the same team, so it is.
So the question is the platform team different than the monitoring team? No, it's the same team. We run we build our Kubernetes clusters, we build our monitoring stack, we build tools on top of that, and we build a bunch of tools to onboard and make all these, logging is automatic. We didn't show a demo of logging, which isn't really exciting, but logging becomes automatic just like telemetry is automatic, and some of these other services are automatic too. How big is How big is our team? So our team is also responsible for operations across the board of all cloud applications. We're around the clock. We have an FTE part and a partner part of our team located in multiple places. So we have the world covered from Seattle. We're located here, T-Mobile's headquartered here, Dallas, Atlanta, and in India, and soon Estonia. So that team overall is probably somewhere around 60 people that covers all 70 applications that are on the cloud and all 70 applications that are inbound on the cloud.
But the core part of Kubernetes and the monitoring is about 10.
Yeah,
10
so the
people.
development team is
it's just about 10 people managing like 14 Kubernetes clusters and 28 Prometheus clusters and about 5 Mesos clusters.
Yeah. And there's other things we do too outside the scope of this talk. So we got the eject button. Okay, any other questions? Feel free to come up and talk to us. Thank you. Thank you very much for coming.
Thank you.